that you all have to dive deep and dive the into the VLSI. So IEEE EDS KLU, which is a electronic. I'm sorry, 1 minute. Am I audible?
Yes, yes, Santosh. Yes, you are
Hello.
audible.
Yeah, yeah. So yeah, IEEE Electron Device Society KL University is a small effort of spreading awareness and the knowledge on VLSI irrespective of the colleges. So now I'd like to introduce our today's speaker, Harshit Gupta, who is currently working as in Intel Corporation as a verification engineer, and he is also a mentor for a lot of aspiring VLSI engineers. So we'll be handovering the session to you, sir. You can take over the session.
Okay, sure. Yeah,
Yes.
thanks, Santosh, and thanks, team. Thanks to the society, right, for inviting me. So I got a chance to interact with the students, right? So I have one question, like, so here mostly students on BTech level or PG level also we have students.
Like they both are we have students from both the BTech level and MTech level, sir.
Okay, okay, yeah,
Yeah.
that's great.
And one more thing I forgot to mention, guys, whoever wants
Mhm.
to ask any questions or anything, you can just raise your hands so that we can unmute you. Yeah, please, sir, you can
Yeah, yeah,
continue.
sure, sure. In between the meeting or in between the presentation, right? You can raise your hand anytime,
Yeah, but
right?
yeah, we'll be having a question QA session, right? So you can ask that.
Yeah, that also we have. Yeah, so you can ask anytime. Feel free to ask, basically. Okay, then let me start. Let me share my screen. Let me know when you can see my screen, right?
Yes, sir, it is visible.
So are we going to record this one or we
Yes,
can
sir, we are
record this
recording
one?
the session. Yeah.
Okay, sure, sure, sure. Okay, then let me start. So yeah. So currently, basically, I'll go through the VLSI design flow, right? And I'll talk about basically what are the total flows, right? What are the steps in designing the chip? Then we will have the understanding of SOC, right? What is SOC and how we are basically doing the verification, how are we designing that complete SOC chip. Then I will discuss about the opportunities, what are the skills, right? And what are the areas or profiles you can target to get a job in VLSI. And in this presentation, basically I'll talk about.
Sir, we can't hear you. Your voice is not clear. Hello, sir. Hello, sir.
Proper circuit on the board. Then we
Hello,
are
sir.
doing connections. Hello.
Sir, you were not audible since few minutes.
Okay.
So I think
I'm not
some
audible.
network issues. Yeah, now it is fine.
Okay.
Yes, sir.
Okay. Now it is audible. So at what slide, right? Which one? I am not able. Like you are not able to hear me from which slide?
Like from starting over, sir. Like your voice was
From
not
start.
audible. So yeah.
You can see my screen, right?
Yes, sir.
Okay. Okay. So basically, I'll talk about. Am I audible right now?
Yes, sir. You are audible. Please continue.
Okay. Okay. Let me know if there is an issue, right? Yeah. So basically, I'll talk about VLSI design flow. What are the flow? What are the steps we are using in designing the chip, right? And then I'll talk about the opportunities in front end. So what is front end like? What are the applications, right? What are the areas, the profiles, right? You can target for get into VLSI. So all the skills required in front end job profiles. That all I'll basically share. So what are the agendas? So I'll talk about the industry, like how the industry evolves, what are the advancements. Then I'll talk about the profiles, which what are the profiles in the chip designing process. Then I'll talk about the skills which we should need for a particular role. Then I'll talk about what is SOC, what are the important components, right? And how are we looking at SOC compared to other systems, small system, IP or subsystem level. Then I'll talk about the front end flow. So in front end flow, basically I'll talk about which job or which area is more basically used. In which area you have so many jobs compared to backend. Then I'll talk about the industry classification, like depending upon your projects, depending upon the products in the market, right? How the industry is divided into several areas. So that I'll talk about. So coming to the introduction, so VLSI basically the revolution came from the integrating so many registers right on a single chip. So how this integration is happening? So earlier, if you go back in the era before the VLSI, so there was this you can see on the right side, right? There is an image in which I have mentioned there is a circuit physical board. So in this board, there are these physical components, right? You can see so these are connected through the board wiring. So these things basically before the VLSI, like there is only this big components that you need to arrange. Then the system, what happens? The system is bulky, right? You can't be these systems can't be portable, right? They are huge in size. They have high power dissipation, right? So all this disadvantage basically limits the use of VLSI, limits the use of technology, right? So before IC could only perform a limited number of functions, right? So what happens after VLSI? So you have all the benefits, right? Reducing the size. You're working at nanometer levels, right? That you can't see from your open eyes, uh, right? So that's the power of VLSI. So what is VLSI is doing, right? So size and power of the circuit, right? They have reduced so much, and you are getting whatever the quality. whatever the speed you want, that you are getting at its best, right? So that what is doing. So and how VLSI is doing like all these things, right? So that is because of some of the technology that some of the components are discovered, right? Like MOSFET, CMOS is there. Then we have the FET, right? These all the components which we are using and making the system very small and high efficient. It has more speed from the previous, right? So coming to the like what is how the chip formation is done from sand to silicon, what is the flow, right? So silicon, how the processor or the chip is made, right? So it starts from just sand, right? So sand has this silicon component, right? So silicon material. So from silicon, what it happens? From silicon, it is your sand is collected, right? High efficient sand. So that is collected and that is basically uh, burnt at the thousand thousand degree Celsius, right? Then it is molded into a container that is a kind of cylindrical. Then from after burning that at the temperature, right? So that sand becomes a takes a shape of cylinder, cylindrical shape. It take then that cylindrical shape is called the ingot. That is called the ingot formation. So from that ingot, we have to chop that slices, right? This you can see the wafer, right? This picture, first picture in which Steve Jobs having this wafer, right? So the cylindrical ingot is cut it into different slices. So these slices are called this wafers. On this wafer, you have different. You can see the rectangular things, right? These rectangular parts. So each these rectangular parts is called the die, right? So first it is cut into wafers. Then each wafer have multiple dies, right? Then what we do? There is a process called lithography. So in lithography, basically there is a circuit printing happens like through the machines, right? So we have this whatever the circuit is there, like whatever we design or we have verified, right? We have made all the things, all the process from front end, back end, all the things we have completed. Then we pass that design to the fabrication lab. So there is a fabrication lab in that all these things happen, like making the ingot, then cutting into wafers, then doing the this circuit printing on that particular die, right? You can see that this single die they have mentioned, and all this circuitry is printed on this die, right? So this die then have all the connections and have the packaging, all the interconnect is imposed on this one. Then it is made a separate product or separate chip, right? Then this package is called the processor. Okay. So coming to the ASIC flow, right? So, ASIC is basically application specific integrated circuit. So there are two flows which are common in VLSI, right? One is the ASIC flow, one is the FPGA flow. So I'll talk about ASIC flow because it is more, I'll say fundamental, right? So I'll talk about FPGA in the later part. So what it happens, one second. Yeah. So what it happens, it starts from the chip specification. So in any industry, if you are going to make a project, right, then you have to basically analyze the market, right, which is specification you want in the coming in the future, what is the requirement, because you can't just have a specification in a few months, right? It takes years, right? Like minimum minimum duration is 6 months. It is 6 months to 24 months mostly. And in big companies, right? Multinational companies, it is sometimes it is more than that, more than 2 years also. So basically, first we analyze the market specifications. What are the things, requirements we want in a chip that will compete with the future products, right, of other companies. So first, our first step is the chip specification. So what we want to introduce in a chip or a product. Then, depending upon the specification, what are the specification we have taken, that we convert it into our design. or our RTL, right? Then there is a design entry. Like we write the RTL, we write the code of whatever the specification we want, what is the requirement of the design, and we write the specification what are our components in that circuit, all those things we want that we write into the RTL.
Hello, sir. Your voice is not audible. Hello, sir. Hello, sir.
Hello, I'm audible.
Yes, sir. Now you are audible. Like a few minutes ago, you were not audible. Hello. Hello.
I'm audible now.
Yes, sir. You are audible now.
Okay, okay. So can you
Yeah.
tell me at what slide I was after you were not able to
Like at
listen?
RTL synthesis, sir. You
RTL
were at
synthesis.
RTL synthesis. Yeah.
Okay, okay. My screen is visible, right?
Yeah, your screen is visible.
Okay, okay. Yeah. So basically, RTL synthesis is the process, right? So we are in a synthesis, we are going to convert the design into the netlist. So a netlist is basically it is a formation of the circuit, right? We have all the details. So design is into the real circuit. So earlier, before synthesis, you can see the design in the code formation, right? So all the codes were there for every component. Maybe it is a mux or it is a sequential circuit or any combinational circuit, right? After synthesis, you can see that circuit in a form of, you can see that particular design as a circuit, right? So after the synthesis, we are going to have the partitioning of the chip. Like we need to decide about the component which are on the chip, like uh, how we are partitioning, like how we are dividing the circuit, dividing the area of the chip for particular circuit, for particular component. Then after this partitioning, we have the DFT, design for test. So in design for test, what we are doing, we are basically doing, we have some fault models, we have some algorithm for detecting and resolving the fault on the chip, right? We have some on-die debug systems, on-die debug components, right? So that they can measure the fault on the chip, and then they can resolve it, or they can basically shut down it, or can do some fix like that. We have that circuitry on it. So in design for test, we are checking about all those models, all those faults we are searching on the chip. After this, we have the floor planning, like in which direction the component should be placed. So on a SoC, right, on a chip, we have so many components. So we can't just place any components here and there. There should be a proper way. There should be a proper data path. There should be a proper communication between the components, right? So for reducing the wire delay, or reducing the whatever the noise is, right? So for that, we should have a proper floor planning, so that it should be efficient to deliver efficiency, right? To deliver a good speed. Then after floor planning, we have the placement stage, right? So in placement, if we are placing those component in the proper area, if we are checking for the efficiency of that component, right? It should be placed at the proper manner, like that. So after that, we have this clock tree synthesis. So if there is a main clock on the SoC, so which is coming from outside, then on SoC it is divided into different clocks, and then it is there is a tree formation kind of thing. So there is a uh, main clock, then there is a sub clock, then these clocks are divided this depending upon the circuitry, or depending upon the systems placed on the chip, right? So after this, we have this routing stage. So we should have proper connection. If there is any connection opened, right? If there is any hang, or if the connection is there should be a connection that should be not complex. It should be easy to resolve. If there is any issue is coming, then the circuit should be able to uh, decode the fault, and basically to do some fix. Then we have the final verification, and then we are basically passing this to, there is a one file, it is we are creating the final stage. That file is then sent to the fabrication lab, and then from that uh, file, we are basically creating we are printing that circuit on this one, right? We have seen, we have to print that circuit on the a particular die which we have taken from the wafer, right? So that's how basically the proper flow is of a ASIC flow. And for the FPGA, so in FPGA, basically there is FPGA is just a prototype, right? FPGA board is a prototype. It is already made build chip, right? So on that, we don't have to go through all the process, whatever I mentioned before. We don't have to have this entire process. So what happens? So after the design entry, so what we are doing? Yeah. So after these things, right? RTL design, verification, synthesis, right? Partitioning of chip, and this design for test. So after that, we can just have the FPGA board. So directly we can check those verification. We can basically check our system, all the verification we can do on that board, FPGA board. We don't have this backend. Uh, Most of this will be replaced with that FPGA board, because it is a already made chip, or already made board. So that's the difference between ASIC and FPGA. In the ASIC, we are basically making the chip depending upon our application. So all the process we need to do in the ASIC flow. But in FPGA, we have this, we have the legacy. So there is already made chip that we can use. 1 second, guys. Yeah, I'm back. Okay, so coming to the next presentation, PPT. So coming to this slide, so what we have, I have divided the this flows, right, front end versus back end. So on the left side, you can see they are the front end stages. On the right side, you can see they are these backend stages, right? So how it happens? So we have the design specification, then we have this RTL coding. So mostly RTL coding is done in Verilog or VSTL. Verilog is more preferable, right? Then we have the RTL simulation. So here we are writing the test benches in system Verilog using the UVM methodology. Then we have this logic synthesis, right? And optimization and scan instructions, right? This is basically DFT. Uh, and then we have formal verification, and then we are checking the timing. So after this, there is a pre-layout STA, right? Static timing analysis. So STA, static timing analysis, basically checking the timing of the system, right? So how your circuit is working, it is working properly, there is a delay, or there is some violation, setup time violation, there are whole time violation. So if any violation is there, then it is basically directed again towards the synthesis, like something has happened here. So some error are in this synthesis or somewhere, right? That is not properly checked. So if it is fine, like if STA, if timing is okay, then it is basically the process is moved to backend side. So then we go to next stage, floor planning placement. Then we have this clock tree, right? Routing is there. Then in the backend also there is a formal verification. So these formal verification are kind of different. So this is kind of a model checking. What is model checking? Means there is a model. So we have a reference model, a golden model. So that is that. So that model we are using as a reference. So we are checking our model, the current model and the reference model. So both we are checking. If it is fine, then again it is forwarded. If again there is a timing difference, like something is messed up here, then again we have to go to this process. Then we have to check if something is not right, right? Then if it is okay, then we are again moving to layout and further steps, right? So this happens if something happens in between the stages, then we have to go back to the again that process, and we need to check like something is messed up. And so basically why front end here is very crucial, right? It is very crucial because of one very important reason, right? That the early you will find the bug, right? This RTL simulation. So if you are able to find the bug in this simulation or in verification, then it is best for you, because whenever you move towards this backend, right, the cost is going to increase. Cost of the resources, right? You will be late in the product delivery. The time to market, your product's time to market will be delayed, right? So that will be basically you will not able to compete with your opponents. Right? So coming to the profiles, right? What are the profiles you can get in VLSI, you can target? So I mentioned these, I've classified the IP associate design engineer, right? So basically who is writing the code for IP or for SOC, or he is integrating. So RTL integration engineer is there. So that what will happen, suppose you are a SOC team. So you have different components in the SOC. So if we have from IP team, you have taken the code of that IP from different IP teams, right? Then you need to integrate that all the IP codes into a SOC. So I'll talk about SOC, then you will understand like how these things uh, happens, right, at SOC level. Then we have the IP SOC verification engineers, pre-silicon validation engineer, right? Then we have this FPGA design engineer, right? All the details. design verification. After design verification stage and the synthesis, so then we have the FPGA board come into picture. So we are doing all the verification then on this FPGA. We are testing this board. Then we have the emulation engineer. So in emulation, what happens, right? Emulation is more towards the hardware. Like in simulation, so there is a very exactly it's kind of duplication of the system, right? So in simulation, we are just mimicking the design, mimicking the environment, and in emulation, we are running on actual system, but that is a kind of duplication of our original system. So it is more towards the hardware, but simulation is totally run on the software, right? And we have the DFT engineer, right? So to detect all the faults, to run all the algorithm, so that our chip can easily find the bug and resolve it. Then we have the formal verification engineer. Then we have the post-silicon validation, right? So post-silicon validation means if the chip is formed, there is a prototype came from the fabrication lab. Then again you need to test it. Whatever the your testing scenarios are there, right? That you need to test on that particular prototype. And after that is done, the validation is done, then you are giving the go to the fabrication lab, then you can basically make so many chips. Then in backend we have physical design engineer, we have synthesis and ST engineer, then physical verification engineer, right? Then the layout design engineer. So how the layout is formed, how we have created the layout of that particular design. Then we have this analog and mixed signal circuit design engineer. So whatever the analog components are there, mixed signal circuit design means like there's analog and digital, both circuits are on the chip. Then there comes this mixed signal circuit design engineer. Basically, he will test this. There's a digital components and there are analog components. So if both are together working properly or not, so uh, that that engineer will test basically. Okay, next. So how the profiles are categorized? What are the demands, versus roles? So in this graph, basically, I have put all the whatever the roles we have, right? Generally, and what are the job demand and what are the profiles in the market. Suppose if you are going for verification, right? So out of 100, you are going to find 55 jobs, right? For verification
Hello,
only.
sir. Your voice is getting break, sir. Hello,
Hello,
sir. Your voice is getting break.
am I audible?
Uh, it's okay now, sir. Hello, sir.
Yeah,
Hello.
is someone asking something?
No, sir. Your voice was breaking the past 2 minutes.
Voice is not good. Hello.
Yes, sir, it is audible.
Okay.
Yeah, you are audible.
Now, hello.
Hello, yes, sir. Hello.
Yeah, is it fine now?
Yes, sir, it is fine now.
Okay. Okay, 1 second. Let me check. Now it is fine, or it is
Yes, sir.
audible, right?
Uh, it is breaking, sir. Your voice is breaking.
It is fine now? Hello.
Yeah,
Okay.
yeah, it
Okay.
is fine now, sir. Yeah.
So, which slide should I start? This one is from where you are not able to hear me. Can you point to the slide? Okay, okay, one second. So can you which slide from where you were not able to hear me?
From pie chart, sir.
From pie chart. Okay. Okay.
Yeah,
Now it's fine. Correct?
yeah.
Okay. Okay. So yeah, so in this one, basically I have put what are the jobs, right? How many jobs are for which role available in the market, right? So you can see in this pie chart, there is mentioned there I mentioned for the verification, article design, synthesis, DFT. Then we have place and route. The PNR is for place and routing, right? So then and STA, static timing analysis. So basically, so if you go for a like if you will try to find out if you want to count, right, so then out of 100 jobs you will find there are 55 verification engineers, right, and there are 15 RTL design, then 9 is for synthesis, then again 9 DFT, right, and then 12% is PNR and STA. So that's the majority of you can see the how the verification plays a big role, right, in the chip formation. So this job this categorization basically this job demands these are basically in India. So this is India, right? India job market.
Sir, your voice is breaking, sir, again. Not audible.
So you can see that verification is at high. There are so many verification engineers. That's why you also see their job. Okay, again breaking. Okay, let me check.
Hello, sir. You are not audible. Hello. Hello, sir. Hello. Okay, sir. Okay, sir.
Hello, I'm audible now?
Yes, sir.
Can you guys let me know in the chat box?
Yes, sir. You are audible.
Okay, okay. Okay, so I was this on this slide, right? So basically, I was just saying here that there are so many roles, right, in verification in the market, right? The jobs are basically pretty high as compared to other roles. Maybe it's a if it is a design or synthesis, right, or DFT or a backend role, right? The number of the jobs, right, are more in verification. And this is the data. This data is basically as per the Indian market, right? So coming to the skills, right? What are the skills you should have for a particular role? So if you're going for a RTL design and verification, right? So you should have a good understanding in digital design, right? You should have these topics. You should have a knowledge in these topics: meta stability, CDCs, basically cloud domain crossing. Like if you are going, there are different domains, right? So there are different frequency domains. Then you're crossing one domain to another. When the signal is basically moving from one particular domain to another, then how you need to deal with it, right? Then we have STA. STA is asked in every interview, right? If it is a front end or back end, in every interview you will find the questions from STA, static time analysis, right? The topics maybe if it is setup time, hold time, the violations they can ask, right? These things they will ask definitely. And you should have a knowledge of ASIC design flow, the complete flow which I discussed, right? What are the steps, what is happening in which stage. They can, the first question, like if I talk my interview experience, right? So the first question was this: what is ASIC design flow? What are the stages, right? So and that is a very important question, right? And then what is FPGA flow? Then you should have understanding in Verilog or VSTL. And for verification, the system Verilog, UVM, right? And computer architecture plays a major role in every interview, right? Then we should have an understanding of protocols. What are the on-chip protocols, off-chip protocols, right? What are the interfaces? Then you should have a basic knowledge of Unix, right? C++ language, then OOPS concepts. So coming to the DFT profile, uh, again, these some of the things will be common in every profile, right? Like digital basic understanding of digital design circuits and these topics, right? ASIC design flow, these things, and the scripting languages are very important, like Trickle or Perl, right? And you should have for a DFT profile. These are the main, basically the hardcore subjects, right? That DFT related topics: fault models, fault coverage, scan chain insertion, this ATPG tool, right? This MBIS architecture, boundary scan. So these are things for DFT. Then we have the physical design, the STA, and physical verification involved. So for this, you should have a good understanding of digital design, right? You should have these are the common topics. You should have basic understanding of diode, BJT, these analog things, right? Analog topics. These you should have good understanding. You should have a knowledge of physical design flow, right? So basically, sometimes interview can ask, right, what is the front end flow or the physical design flow or the back end flow? So you just need to start after the synthesis, right? So before synthesis, all the things are or before DFT. So before DFT, all the things are front end, and after DFT, all the things are back end. So if someone is asking for you the what is the tell me about the stages of physical design flow, then after DFT you need to start. You should not start with first step like chip specification, then you are telling the RTL, right? So you need to analyze the question and then you should give the answer. But what the interviewer is asking, right? Then you should have the knowledge of STA and these STA these type topics, right? Timing checks, timing models, timing paths, different types of paths, setup and hold check, like delay concept, like that. And the basic knowledge of DRC check, design rule check, right? This is basically for the physical verification. LVS check, antenna checks, these things, parasitic and this IR drops. Then coming to the analog design, right, and layout profile. So you should be good in layout. You should be good in understanding of the RC circuits, right? Analyzing the circuits. This IC fabrication steps, right? So this IC fabrication steps are other steps which I told you from sand to silicon, right? That from sand, the ingot formation is happened. Then after that, it is cut into wafers. Then on each wafer, we have the die. Then we have the circuit printing on each die, right? Through lithography process. So all these are important. So next coming to the front end, right? Why it is in demand? Why there are so many jobs in verification, right? So front end basically, I have here only mentioned design verification, right? But DFT and synthesis is also part of front end, right? So for design, right? So for design, we have the RTL design, we have the RTL integration profile, right? And in verification, there are different types of verification. There are functional verification. So functional verification is basically we have some scenarios, we have some test conditions, right? So for that, we are writing our test benches. We are basically verifying those test benches on a particular RTL or a particular design, right? What is power aware verification? So in power aware verification, basically we are taking the, suppose a circuit is there. Suppose there is a gate or there is an AND gate, right? So there are two inputs A and B, and there is output A dot B, right? So, but what about the power rails, right? What about the VDD? What about the ground, right? So when the circuit comes with power rail distribution network, right? Then it is power over verification. So in that we define all the power rails, all the power domains in our circuit, like which component is going to work on which voltage, and which component is going to take which power, which is the power dissipation of that particular component. So with power other things, right? So this power verification is one. Then we have the emulation. Then we have the formal verification, right? And these I have basically classified these things verification into two parts, right? Static verification and dynamic verification. So what is static? Static means we are not running any simulation or we are not running any emulation, right? We have the circuit or we have the design, we have the RTM basically. We have the synthesized RTM. We are doing some checks on those RTM using some apps, like for formal verification. So in formal verification, there are different types of things we can do. So let's take example of you want to do a connectivity check. Suppose there is a one signal from block A and it is moving, it is going to block B. So suppose I want to check the connectivity between A and B, that this signal is initiating from A block, and if it is reaching on block B or not, right? So that we can do through a particular app. We should have the RTL, we should have the scenario or the assertion, you can say. We can write the assertion or condition that it should initiate from A and should reach to B. That's just a static check. We are not doing any simulation. We are not doing any timing things there. We are not checking at a particular time like that. So those are static verification. There is no timing in this verification, right? And in functional verification, power over verification, all those timing is there. Like we are running a dynamic verification, right? So in dynamic verification, we are running simulation or emulation. We have the sequential things in our verification. We are checking at particular times, right? So why it is in demand? Why the front end? There are so many jobs in front end, right? It is because we have the more engineers, right? So there are more need in the market, right, for front end, because verification takes a huge time span of a project, right? So we are doing verification for a long time. Like it is, we have to test so many scenarios, right? So many things we need to test. Why we we are doing so many things in the verification because we want to find the bug at its early, right? So the early we will find the bug, the least will be the least will be our cost, right? We will be able to we will able to maintain the time to market, our product time to market, right? That thing we will to compete with our opponents, right? uh, and that's, and also there is less experience needed during recruitment, right? In front end. Because if you're going from starting phase to the end phase, right? So the expertise is increased, the experience required is increased, because at the later stage of your product, right? At the later stage of your chip designing, there is a very less error of we cannot we cannot basically have the errors, right? We should have less errors there, because then again we have to start the entire process again, right? We need to go to again back to the one of our stage, right? So we can't have that error at the later stages. In initial stages, you can have the error, you can have the bugs. In the verification this stage, you can have the bugs, you can fix it quickly, you can fix it, right? But if you are in the later stages of your ASIC design flow, then it is very costly to fix the bug there, right? So that's why it is most important thing in your chip design. So what are the things, or what are the setup, right? We have for code, RTL coding and verification, right? So for RTL coding, you should have a design category, right? So for which design you are writing the code? Is it a sequential circuit? Is it a combinational circuit? So for all these design categories, you have a different design styles, right? Then what is your coding style, right? How the well structured your code is, how clear and concise it is, if it has the complexity or not, right? So we need to minimize the complexity as much we can, and we need to minimize the depth of the design, right? So it should not be in too depth, right, your design, so which will make your system complex. Then we have the verification. So in verification, what we do, so we have some inputs, right? So we write the test bench. This DOT is basically this is the design, our design, right? So this we took from this team, RTL team. So there is a RTL team, there is a verification team. So RTL team give the code to verification team. Verification team writes the test benches. So it is a part of test bench, right? This one, upper side. So in the test bench, you write the some cases, like on that case, I want to check this circuit, right? So suppose there is an AND gate. So in AND gate, you have two input AND gate. So there is two inputs A and B, right? So it's your choice, right? If you want to give 0 0 0 1 1 0 1 1, right? Which case you want to test on your design. So then that input you'll give to the DOT, right? You will run the simulation, you will get the output. Then there is also a component of the test bench, which is a monitor. Then we have the scoreboard. So then in the scoreboard, then you can see, you can basically compare. So this is your output. So in the verification, we have one reference model, which is basically our or you can say there is one uh, specification, right? So with which I want to check. So there are two values, right? Actual value. Actual value you will get through the output after running the simulation. And there will be a one reference value. So you need to compare with the reference value and the actual value. So if that is wrong, then the scoreboard will show, hey, this is you're testing this scenario, and this is the value, the output you are getting is wrong, right? Then you again need to do something here. Like if you have done something wrong in your test bench, right? And if not, if you have written the right test benches, everything is proper, then still you are not getting the proper result, right? Then there is a bug where bug is in the design. So design team has done something messy, right? They have written some wrong code or something they have messed up. So we will basically file a bug, or we will tell our team that, hey, here is the error, we need to fix it. Then we can run our simulation and then we can pass it, right? So this is the flow. So then coming to SOC, right? What is SOC? So SOC is basically system on chip, right? So I have taken one example of mobile SOC, right? You can compare with any mobile SOC, right? You can take the example of Apple, right? Apple 15 just launched, right? So you can relate with that. So in Apple SOC, they have released this new chip, right? A16 Bionic chip, right? So in that chip, what are the things we have, right? We will have the camera, right? In the SOC, we will have the camera, we will have the sensors, we have the display, right? We have this we have the CPU, we have the GPU, right? We have the memory. So all those things when it comes on a single die, right? If we are placing all those things on a single die, then it is called the SOC. So SOC is basically bunch of agents under one roof, right? Requesting for resource, which is memory, right? So if anything is running on the SOC, it needs memory. If it is a program or it is a data, right? So both are in memory. Without memory, SOC is nothing, right? Any system without memory is nothing, right? So memory is the queen here, right? So what are the agents I mentioned? It is the core and IO devices, right? What are the core? Core is basically doing all this. So inside CPU, we have cores, right? So cores are doing this uh, operations, right? Whenever we are giving instruction, like there is ALU, right? Arithmetical logical unit. There's a control unit, right? These things, some operations basically done by core. So, and what are the IO devices? IO devices are your sensor, your camera, your this video codec, right? So codec is basically it is a compression decompression component basically. So this basically convert your if there is a video file, right, MP4 file. So that codec will convert that file into a video, right? So that you can see on your screen. So it converts the data into whatever the need of a user, right? So there are different codec, audio codec is there, video codec is there, right? So and there is a GPU, a graphical processor unit, right? So this processor is for graphics. This processor is basically doing all your instructions, whatever it is calculation or other operations, right? That is for this. So what are the components basically in SOC, right? So it is core and IO devices, memory. We have the interconnects, right? You can see the interconnect, SOC interconnect. We have the bridges. We have this bridge, right? This bridge is basically connecting all these components on SOC. Then we have the clocking units, reset units, controllers. So all these things come on a single chip, single die. So everything we are taking onto this, uh, you can say different IP on a single die, right? So this will called as a SOC. So how the SOC evolution, right? What is the SOC evolution? So evolution is come basically what we are going. If you compare with your old phones, right? Your old smartphones. So now you say when there is a phone advertisement, right? So in any phone specification on some sites or any job in any advertisement, right? So you'll say the company is advertising, right? It is a quad core, it is octa core, right? It's a multi-core processor. So what is that? That is basically how much core you have, right? So how your house? Just one second. Give me 1 second. My system is hanged. The screen is unshared, right?
Yes, sir.
Okay, okay. Something has happened in my laptop. 1 second. Share again. Now it is shared.
Yes, sir, it is shared.
You can see my screen, right?
Yes, yes, we can see.
Okay, I was on this slide, right? SOC evolution. Yeah. So basically, what is happening here? So from single core to you are going to multi-core. Why we are going? Because if we have the multiple CPUs, right, and we have multi-core, so our basically whatever the operations we are assigning to our devices, right, that it will do efficiently because all these things will work parallelly, right? So the more we have the processor, the more we have the core, right? Uh, so then more it will work efficiently, right? If we have the multi-core, then it will be very fast from a single core processor, right? So the cores in a processor are increased, right? So the more the core, more the efficiency, and more it will basically deliver your fast operations. So now comes the chiplets, right? So after SoC, we are basically moving into the chiplets. So now you understood, right? What is SoC? SoC is basically just a bunch of IPs we have integrated on a single die, or it is a single substrate is there, right? And on a single platform, all the IPs are on, right? Now, if you go to the chiplets, what are the chiplets, right? So this is currently is in trend, this chiplet products, right? Because they are very high advanced interconnects are there. The packaging technology is improved. That's why we have basically the projects are now having the chiplets. What is chiplet? So left side you can see it is a SoC or a monolithic chip. Monolithic means there is only a single substrate is there. On that single substrate we have different IPs. We have integrated that IP, all the IPs, right? And then we are using singular piece of silicon, right? Single silicon is there. But what happens in chiplets? So chiplets is a heterogeneous collection of chiplets. Means suppose if you have one IP or if you have one subsystem, like group of IP, so you will make it as a chip. You will basically make what you will do. You will design it, right? You will do all the process of ASIC flow. You will scale up it to up something, scale it to up to some nanometer, right? Technology scaling you will do. You will make it as a chiplet, separate product, right? So in chiplets, what you will do, you will basically integrate different products on a single platform. But now the silicon is not a singular silicon, right? It is not a single silicon. They are different substrate now. These things are different. Uh, Each block is different. Each block has the different process of formation, right? You can have the different technology scaling also, like the size, right? Some chip is 10 nanometer, some is 14 nanometer, right? Different chips you using basically heterogeneous collection. So what it will do, it will basically reduce your cost, right? So now you don't have to go through the complete process. You just basically take it from like if there is a memory, you will take it from some vendor, right? And you should not be able to invest so much time in a single product. So your time to market will be reduced, right? So your yield will increase. What is yield? The chip yield is basically like how much you can integrate on a chip. How is the area utilization, right? So now you will basically say, hey, I need 10 nanometer chips or I need 7 nanometer chips, right, from a vendor. That vendor will give you that chip, and then you can basically integrate on your system. So that is how a chiplet is formed. So this one you can see here, multi-chip module. So chiplet is basically multi-chip module. Multi-chips are on a single platform. So you can see there are different ICs of different technology. Suppose this is a memory IC. This is different IC. This is GPU. This is CPU, right? So if all these things I want on a single platform, then I will take it from this one and under chiplet, right? Multi-chip module. So then I will assign this one on a single platform. So then it will be easy for me to compete with the other industry, right? Other competitors, right? So then I can make the chip in a very less time. And so what I need to do, just I need to rearrange these things. I need to basically analyze, and depending upon our requirements, right, we can easily make the mix. We can do the mix match, and then we can have the project or the product ready. right? So now comes the industry classification, right? So what are the industries in semiconductor? So in semiconductor, we have these broadly I have divided into these three companies, right? Like we have product-based companies, we have service-based companies, we have EDA companies, right? EDA and tools companies. So in product-based companies, you can see which companies make the processor. So I have named some companies like Intel, Nvidia, AMD, ARM, right? So these are basically making the processor. There are some wireless products like wireless communication and there are some communication chips, right? So that is going to be made by Qualcomm, Cypress. They are the automotive area, like in the automobile industry, right? So also the chips are used. So those are made by Infineon, NXP, and we have the mobile SoCs. So these are basically related. We have the some recognized companies, right? Apple and Samsung. Coming to service-based companies. So what the service-based companies are, right? So they provide the resources to a multinational company or a different company, right? So suppose in a company, right? In Intel, suppose there is one project, you need some resources, right? You need some engineers to work on. You don't have the basically for a particular project for some time you want some resources. So basically you will hire from TCS. You'll say TCS, I want these many candidates in this profile. So for this project, right, for a 1 year or 2 year, then it will provide the services to this company for their product development. Right? Then we have the EDA companies. So whatever the tools we are using in all the stages of ASIC flow or our chip designing, right? So these companies provide all the tools like for simulation, emulation, for chip partitioning, for physical design, right? For layout formation, for your STA, right? Static timing analysis, for formal verification. So whatever the tools are there, those are going to be given by these EDA companies, and they will support it. Like suppose you have some issue in the tools, then you can directly contact to the cadence team or the synopsis team, right? So that guy will tell you, hey, do this fix, and the tool will work like that. So these are the companies basically which we have generally. Uh, yeah, so that's all for the day. So we can, if you have any questions, then we can start the Q&A session.
Thank you, sir. Thank you so much for the session. It was very informative.
Yeah, thanks.
So, guys,
Thanks.
if you have any questions, just you can raise your hand so that we can unmute.
They can unmute themselves, or you have to,
No, sir, they cannot unmute themselves. I'm unmuting them. Yeah.
or you can basically someone can raise the hand and then you can unmute. That will also good. Okay.
Hello. Hello.
Yeah, I'm seeing some hands up.
Hello.
Your voice is low.
Is my voice audible, sir?
Yeah, yeah.
So I have a doubt on AI, sir. How the AI will affect the verification engineer role, sir? Like there are different AIs coming in
Mhm.
present trend, no? How these
Correct,
will
correct.
impact the verification roles?
Yeah, yeah. Basically, AI is for everyone, right?
Yes, sir.
Maybe it is a every engineer, right? Artificial design engineer, physical design engineer, right?
Yes,
Verification
sir.
engineer. It is going to affect everyone. But the thing is, it is not eating your jobs, right?
Yes.
Basically, you need to know how the AI works, right? How you can use the AI to improve your work, right? It is
Yes,
just
sir.
that you don't need to be worry about that. You should
Mm.
basically be aware more about that,
Mm.
right? You should know how the AI works, right? So if the AI is coming into picture in your role, then you need to understand how I can basically take the advantage of that,
Yes.
How I can use, how the application of that one I can implement in my role, right, in my work. So no need to worry about that. You just need to aware of it, right? You need to have an idea like how to use that AI, right?
Yes. And one more question is like, do you have we have different types of verifications, no sir? I've just
Correct.
heard about the CocoDB verification using Python. What is the difference
Mhm.
between the CocoDB verification and general verification?
CocoDB verification.
CocoDB. It's
Not sure
Python
on this one.
verifications.
Uh-huh. Python-based
Yes.
verification. So you're writing test benches in Python,
Yes, sir.
am I right?
Yes, sir.
So your question is, what is the difference between that verification and
And general verification will follow test bench sequential. We have a test bench structure, no sir? That one.
correct? Yeah, that's there is mostly hardly any difference, just the difference of the language, right? Suppose there are some components in the verification environment, right? Like some UVM components are there. So if you're writing that components in the language, right, it's just a language difference. Like you can write it in system Verilog, you can write it in Python, you can write it in C++, right? So in any
Okay.
language you can write, but the methodology is same. Whatever
Okay.
the methodology you are using, right? UVM, OVM, right?
Yes,
XVM,
sir.
whatever you are using, that is same. Throughout the verification, that is same. Just the language you have taken different. So
Okay. Now,
it is same.
currently,
Just the language.
currently is the currently in the industry they are
Mhm.
using CocoDB Python verification.
Correct. Yeah, Python is more into the picture. But
Yes, sir.
traditionally, if you'll say normal verification or normal project, right? Still they are using system Verilog. Like
Yes.
currently, I'm doing my project is on basically server chips, right? So
Hmm.
for data server, we are designing one chip. So in that, we are using system Verilog only. There's no
Okay.
Python in that one. Yeah. So that is the latest. That is basically that is the latest project, not some old or some model, some project that is not normal or traditional, right?
Yes.
Yeah.
Okay. That's it, sir. Thank you, sir.
Okay. Yeah. Anyone? Yeah, Santosh, can you unmute? Because there are some hands I can see.
Yes, sir, I have unmuted.
Hello.
Arjun, yeah, you can
Yeah.
speak.
Yeah, good evening, sir. Sir, actually, can
Hey.
you throw some light on the salaries one can expect after joining the VLSI
Okay.
domain?
Yeah, I missed that part actually.
Yes, sir.
Okay. Yeah, actually that is the most important thing. That is the motivation, right? So, okay. So, average salary you'll basically it depends, right? It depends your academics, right? Your college, from which college you are graduating, uh, like, or it depends on the company, right? If it is a multinational company or the service-based company, right? So I'll talk about then MNCs, right? Because whatever the experience I have. So in Intel, in NVIDIA, right? So these companies basically, if you are in tier one college, right? If you are from an IIT or from a good college, right? Then the salary basically they took from internship, right? From IIT, they took directly as a full-time candidate. But there are some colleges like I'm from Manipal, and from Manipal, some private colleges are there, right? Like Manipal is there, BITS is there. So they took from there as an intern. So as an intern, they give you around 40 to 70K, right? And after conversion, they will give you around 12 to 20 LPA in between, right? As a full-time. And if I talk about the IITs, then currently the package I think it is from uh, it is around 15 to 20 LPA. And if I talk about normal college, right? So then it is around average package is around 8 to 12 for a full time. But in service-based companies, it is kind of low, right? Like it is around you can approximate take 5 to 10 LPA. That is a fresher salary.
So, sir, are these salaries after MTech or after BTech?
Your voice is breaking actually.
Sir, I wanted to know that the salaries you are telling me. So the salaries you can expect this
I'm
after
not able
MTech
to
or
hear you,
after.
Arjun. Actually, your voice is breaking. Is everyone? Are you guys able to listen, or is this issue on my side?
Actually, his voice is breaking, Arjun.
Okay, okay.
Okay, sir, now is it?
No, it is not fine.
Oh, so maybe I should type it in the chat box.
You can type the question in the chat, right? Then you can answer. Yeah, these Arjun, these salaries I mentioned for MTech actually. These are for MTech. For BTech, it is little less, but not much difference. Yeah, other question. It
Yes,
is
sir. What is meant by post-silicon validation, sir, in VLSI?
yeah. Post silicon validation is basically like suppose you have gone through every step right once. So in VLSI in chip designing stages, right? What happens? It is not a sequential process, right? Like first thing is happened, then second will happen. It's not like that. It it worked as a pipelining, right? Suppose you have started writing the RTL. So you RTL designing is done, right? Then you will release that model to verification. So now RTL team's work is not done, right? RTL team will still work. Like new feature will come, then they will modify their RTL. Then they will release a model. A release model will be there, right? They will release with the tag that this is the tag of this month, this article is released, right? And verification will team work on that one. Then again after 1 month, again they will release a RTL, right? So it is not like there is a sequential based process. It is a pipelining. So all teams will work together, right? So what happens in post silicon? So one for the first time when the steps are completed, right? So the fabric the basically we will send the design to the fabrication lab. So from fabrication lab, they will basically made a prototype, right? They will not do all the chip formation, right? They will not basically made the products right in bulk. They will just they will just make some products, right, for prototype or testing. Then that prototype will come to our company. Then we will test that one, right? So that is post silicon validation. Means your silicon is made, you are testing on that silicon. So basically you are testing on that particular chip, right?
Okay.
So that is a post silicon validation.
And
After
pre-silicon
silicon,
validation, sir?
pre-silicon is just before silicon is made. Mostly, you will say the silicon is not there. You are just running your simulation or emulation on some softwares or some devices, right? So it is before the process, before the silicon is made or the chip is made, right? That is pre-silicon.
Another doubt is when will be recession end, sir, for VLSI industry?
Research and yeah, like you can see right there now the companies have started recruiting, right? But they have basically limited to 2 to 5 years, minimum 2 years they have now
Yeah,
they are
sir.
taking. So
When
soon
when
there
they will
will
be hired for
be
freshers?
job for freshers.
When they will be hired for freshers, sir?
It is like date is not basically exact date. I can't tell you, right? maybe in this quarter or in the next quarter, right, you can see some jobs for freshers also. Because in this quarter, right, currently companies are basically recovering their losses, right? They're coming on track. So after this happens, right, they have all the losses recovered, then they will basically have the more openings. So then they will take for freshers.
December, sir.
Hello, sir.
Yeah, hi.
Hello, sir. What is the main difference between formal verification and functional verification?
Yeah. So functional verification is a dynamic verification, right? So you need to write the test bench for a design. Suppose there is a design, like there is a mux, right? There are different inputs and outputs, right? So like there are inputs in the system. So basically for testing that mux, right, you need to write a test bench. In test bench, what you will write that your input should be this one, like you're testing 0, 0 or 0, 1 or 1, 0, and your output should be this one. If this condition verifies, then your functional verification is done, right? And that verification you are doing through running some simulations, correct? But in formal verification, you don't have to write any test bench, right? Nothing you have to write. You have to write just some scenario, some check conditions. So you have the RTL, you have some check conditions. Like you will write that at point A, or at this point, I want this input and this output. So you will basically directly feed that input or your scenario or your checkers into a tool, formal verification tool, and that tool will quickly give you the results, right? Like in verification, like in functional verification, it takes time. Simulation takes time. It will run for some time. Like if it is small IP, then it will run in less than 1 hour, right? If it is a subsystem, then it will run around 3 to 4 hours, right? If it is a SOC, then it can take up to 3 days. And if it is about chiplets, right? So currently my projects uh, is a chiplet, right? There are different SOCs are running. So that simulation is taking around 7 to 8 days, right? So for more than 1 week, I'm running one test case. So that's the worst part in a simulation, right? It takes time. But in formal verification, it doesn't take time. In just few minutes or few hours, right? Not few hours also. Under 1 hour, it will give result.
Mm. Okay, sir.
So
Good evening, sir. Am I audible?
hello.
Hello.
Hello, sir.
Yeah, you are
Yeah, am I
audible.
audible, sir?
Yes, you
Yeah.
are audible.
What I want to ask is like, see, uh, speaking of realistic thing in BTech, only we have from what you have told, what I've understood.
Your voice is low. Again, your voice is low.
Now, now,
Now it is better.
hello.
Mhm,
Yeah. See, in BTech, only thing we learn is Verilog, Python, and about
mhm,
microcontroller, embedded C, etc. But
mhm.
from what you have told us, we need much more things like all this RTL, STA. We need to learn all those things.
Yeah. Basically, you need to choose. You can choose a role or a particular area, right? Like front end, if you want to go to front end or back end. Then in front end, if you want to go to verification, then you need to have some skills, right? Which I mentioned in my presentation, right? So
Yeah.
those skills you need, like system Verilog, you need UVM, you need one protocol, right? You should have understanding in one product protocol. So
Okay.
those things are basically very important.
But when we look at the overall career growth aspect, like what do you think, sir? Like BTech, learning from BTech only is good, or pursuing MTech is a good idea,
Pursuing
career-wise?
MTech will okay. Yeah, MTech will definitely help you, right? Because
Yeah.
in MTech you will have the more exposure to this industry, right? You will
Okay.
basically you will not learn other subjects right there. You will learn only the front end and back end only. Only those topics like physical design, verification, digital design, right? IC
Yeah. Yeah.
design. Only those things, fabrication you will learn. So all those things you will learn there. That's why it will give you another edge, right?
Yeah.
Against a BTech student. But for a BTech student, right, if you are getting a job after BTech, if you are getting a job in a normal company or service-based company, right, then it is fine.
Yeah.
Like you can have the experience. Like 2 3 year, you can basically learn everything at IP level or basic or very small level, right? You should learn to create test benches, how to do verification, or in any area like in STA, how to do the timing analysis, right? You should learn the tools. So if you'll get the experience there in 2 3 years, right? After that you can switch to the MNC, right? Top companies.
Yes.
Then
Sir, thank you so much for
or there is one option, right? After having the experience in 2 3 year, right? In after BTech in any
yeah.
company, you take the experience of 2 3 years, right? Then you can also do the masters from a good college or from outside India also you can do some masters. Then after that you will get a huge jump, right, in your career, because
Yes.
masters give you a great jump in your career, right? Great growth if
Yeah.
you go for a masters.
Okay. Thank you
Sir,
very much, sir. Thank you.
Hello, sir.
Right. Yeah.
good evening,
Yes.
sir.
Hello, sir.
Yeah. Good evening.
Hello.
Hello, sir.
Yeah, sure. Yeah.
Sir,
Yes, sir.
what is the main responsibility in design and verification, sir?
What is, sorry?
In design and verification role is there, no? So we need
Mhm.
to create a design and verification. Both we will do in that role, sir.
No, that is, both are different roles, right? So there will be a design team, there will be a verification team. So design team will do their work, right? They will do all the RTL coding, right? They will write the code for all the components. They will integrate it, right? Then they will forward it to the verification team. Then verification team will write the test benches. They will write their code, and then they will run the simulation with that RTL given by the design.
Okay, okay. Thank you, sir.
Hello, sir.
Yes, yes.
Sir, as a BTech student from non-IIT and NIT, like from Tier 2 or Tier 3 college, how we can get into this VLSI industry?
Yeah, so basically you have 2 3 options, right? You can do, first option is you can do masters, right? Then you can do basically you can join, there is one institute, CDEC, right? You may heard of CDEC. You can do the course from CDEC. It's a 6 months course. Then there is an option of doing some internship, taking some internship from any training institutes, right? There are
Yes, sir.
some VLSI training institutes, right, that you can do. Or if it is possible for you to prepare by yourself, right, that also you can do.
Yes, sir. But how can we get this opportunity to attend the interviews or to internship, to get internship?
For internship, no, for internship that you can directly apply, right? Basically you should do some projects. You should have some certification in your resume, right? So your resume should reflect that you have done something. Then only the recruiter can think, right? Then he can consider. So basically you can do some courses, you should have certifications, you can do some projects. That will be normal projects also you can do by yourself, right? You can take the reference of GitHub or the online resources. You can do that project. You can learn some protocols. You can do the projects on that protocols, right?
Yes, sir.
So that way basically you just need to create a resume that will so if you will apply for a job, right, that the recruiter can say that yeah, there is some weight in your resume.
Yes, sir.
Yeah.
Sir,
Yes.
hello, hello, sir. I have hands-on
Sir, about the
experience in
scripting language,
verification.
which should we choose?
Which one? Scripting language?
Which one is choose to for the best? Yes, sir.
Scripting language, right? Okay. So basically in front end, Perl is used. Perl and Python are best, right? And in if you considering for backend, right? So for backend, mostly the Tickle language is widely used, like in tools, EDA tools or other tools, right? Backend tools. So their Tickle is very important, and in front end, Perl and Python. These two are very important.
Sir, what
Yeah,
for the
training
front end?
for front end, Perl. Let me type in the chat box. Perl and Python.
Okay, sir.
Hello, sir.
Yes.
Hello, sir. I have hands-on experience in verifications in protocols, for example, ASP and APP.
Mhm.
But I put in resume also. I applied in some internship recently called in Synopsys
Mhm.
verification interns. But I applied so many companies, but then they could not any response till now, sir. How they we contact and how we searching for jobs.
Okay. Okay. Basically, what is happening, right? Even to internships, right? The experienced candidates are applying, right? That's the unfortunate thing, but right. So nowadays, like to even a 0 to 2 years experience, right? The candidate with 5 years or 6 years, he's applying because in the recession, so many people have lost their job, right? So
Yes, sir.
currently the jobs are very less. The jobs are in the market, but they are very less, and the people are applying like they want jobs, right? That's why high experienced candidate also apply to the low experience job. That's why even to the internship experienced guys are applying, right? That's why for freshers it's very tough time right now.
Okay. When will be hiring for freshers, bro? Freshers, sir.
Yeah, mostly in coming months, right?
Sir, any December or October or November, sir? Maybe, might be.
Yeah, coming this September is there, October now. Yeah, around December you can expect like, uh,
Yeah.
but I'll say early before December only. I think there should be jobs, right,
Okay.
for freshers.
Okay.
So I've also shared my LinkedIn this one, right, profile. So
Sir, I will
any kind of
contact you in LinkedIn, but I will message to
yeah.
you, but you are not responding.
Okay, okay. Yeah, actually, I was preparing this presentation, right? That's why I
Hmm.
was not active on LinkedIn so, last few days. Yeah,
Okay, sir. Upcoming days, I will
yeah,
contact you.
yeah, 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 yeah. I will reply. I reply actually. It takes some days, but I'll reply, or I try to reply all the
Okay.
uh, everyone, right? Or if you basically connect with me one to one, so there is one this topmate site, right? So there also you can connect. Let me share that link
We are
also.
connecting one to one in top notes, sir.
Yeah, yeah. Basically, if you want to talk with me, right, or if you want to discuss something, your resume, or like how you can improve yourself, right? What are the things you need to prepare, and if you are doing in the right direction or not. So for that, basically, there is one site, right? So
Yes,
there
sir.
you can connect with me.
But
I'm sharing
already
that
I
link.
done training courses in
Mhm.
VLSI courses,
Okay.
but still I am looking jobs.
Okay. So you have the experience, hands-on experience.
Yes, sir. I have hands-on experience
Okay. So
in
from where you have done the training and all?
Maven Silicon, Bangalore, sir.
Okay, never sleeping, right. Yeah, again that's the issue, right? That basically jobs are very less, right? So
Yes,
currently
sir.
what you can do, right? Whatever the opportunity you are getting. So you should apply basically as much as to the internship, right? So the internships you have the chance, but in a
Yes,
full-time role, there is hardly any vacancy, right now.
yes, sir.
And if
Yes,
there
sir.
is a vacancy, but experienced one, they are taking that one.
Okay, sir.
Yeah.
I've got a question.
Yeah. So Santosh, can we wind up or is there any
Yes,
doubt?
so we are good to wind up. So
Yeah,
I almost
Sandhya,
all we have
Sandhya
covered all
is
the
asking
things.
something about to ask. We can take the last out, then we can wind up. Yeah.
Yes, sure, sure.
Question like, if we
Yes,
work in a
Sandhya,
service-based
do you have any
company,
doubt? Yeah,
Am I
any
audible?
doubt? Yes, yes, yes.
Yeah, sir. Like you told, we could take experience from a service-based company, but like, are
Hmm.
there any roles where uh, they demand us to have an MTech degree as a job requirement itself, or will
Hmm.
BTech degree be enough for all roles?
No, no, for yeah, yeah. Actually, it depends on the company, right? So mostly they don't require MTech, right? But it totally depends on the company. Some companies basically are okay with the BTech, right? So, so it totally depends, right? So you will get also uh, you will get the companies with BTech also and for MTech also. It's not like that every uh, service-based companies is recruiting for MTech. It's not like that.
Hello,
Okay, sir.
am I audible?
Yes, 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 you're audible.
Evening, sir. When it comes to projects, what are the trendy projects in VLSI industry? Can you share some insights about them?
Okay, trending. You mean in which area you want? Front end,
In
back end,
front end
front end verification or design?
verification.
Yeah. So for verification, basically, currently the best projects you can do you can learn some protocols, right? Like PCI or Ethernet. These two are the important protocols right now. In every project you will find these protocols, right? So you can do the verification of PCI protocol. So you can implement that PCI architecture and basically do that one. So any protocol verification is a good project right now.
Sir, in designing,
In designing, then in design for design, I've shared one post actually on some. I've shared some projects, right? Verilog projects. You can see on my LinkedIn page there is one post. So I think few days back only I posted. So in that you will find around 200 plus Verilog projects, right? So there you can see all those projects are good actually, and I've shared the GitHub link also. So
thank
there
you.
you can basically, yeah, that's thanks. Okay, yeah, Santosh, we can wind up actually. I've also uh, to
Yes,
go.
yes, we can wind up. So we have answered almost all the questions. So thank you, sir. Thank you so much for spending the time with us. This session was
Yeah, yeah,
very
of course.
informative.
Mhm.
Surely we'll be arrange another session sometime soon.
Yeah, definitely, definitely. Yeah, it
Sure.
was good talking to you guys, right? So actually, I also wanted to communicate with you guys, but in industry it is hardly possible, right?
Yes,
That's
sir. Yeah,
why
yeah.
I shown the interest, right? I showed
Yes.
the interest. So basically, the norm, basically the global advice, right, to all of you guys, right, is that you just need to work on your skills, right? Just gather whatever the skills I have mentioned in the presentation, right? I'll share the presentation also
Sure, sir.
with
Sure.
more info. Yeah, I have to add more resources in that one. So the salary part I'll try to add. So so basically you need to target. It is a point, right, in the right now in the market, right? You can't have all the things. So basically, my advice will be that you should basically target one profile. Maybe it is a front end or back end, and in front end also you focus on a single profile like design or verification, right? Then you gather all the skills in that profile and then apply to the roles, right?
Sir, one last
Basically.
doubt.
Mhm. Yeah, ask us.
What about the projects in RTL?
Projects in RTL. Yeah, that only I told you, no? That is design, uh, RTL designing, right?
Thank you, sir.
Yeah, those are there. Yeah, in on my LinkedIn post, right? I'll also. Should I share the link of that post?
Yes, sir. Please.
Okay, one second. One second. Okay, got it. Yeah, I've shared.
Thank you so much, sir.
Okay, no problem. Okay, yeah. So all the best to all of you guys, right? So keep preparing, and yeah, the situation will go better, right? It will become better, and you'll get a good response. Okay,
Yes,
Thank you.
Santosh.
yes, sir. Thank you, sir. Thank you
Yeah,
so much for
no
your time.
problem. Yeah. Okay, yeah. Okay, thanks everyone for attending the session. Right? Okay, bye bye.
Uh,
Good night.
Good night, sir. Guys, you can fill out the feedback form which we have shared in the comment section.
Sir, given certification, sir.
Santosh, they are saying that unable to fill. Once check the link.
The link is working.
Sir, if you fill feedback form, if you in your side given certification, sir.
Okay, certificate. Actually, we'll not be providing certificate for this session. That's why. But we have not decided that yet. So once we will verify with our team, once we'll discuss with our team, so then we can share the certificates also if we will be providing to
Okay.
the people who filled the form. Yes,
Okay. Okay.
yes, guys. So guys, we are going to wind up this session. We'll be floating this feedback form in our official Telegram channel, so you can fill out from there. So we'll be winding up this session. Thank you, guys. Thank you so much for attending your time. Thank you. Yes, Hruday, we can wind up the session. We can stop the recording as well.